Hi everyone, here we have a very nice equation to prove for the value of n. So in this equation we have to find the value of n. The equation is 4 to the power n to the power 4, which is equals to n minus 1 to the power 4. So let's start our question. Firstly, what I'm going to do, I'm going to shift this to the left hand side. So n to the power 4 minus n minus 1 to the power 4, which is equals to 0. So next I have the minus sign and I can write this as n to the power 2 minus n minus 1 to the power 2 to the power 2 to use this identity, that is a square minus b square, which is equals to a minus b and a plus b. So I'm going to write this in this form. So I can write this as n square, firstly in the positive, n minus 1 square, and then I can write this as in the negative. So n square minus n minus 1 square, which is equals to 0. So let's open this square. N minus 1 square as a minus b whole square is equals to a square minus 2ab plus b square. So use this identity here. It will be n square plus n square minus 2n plus 1 and n square minus 2n plus 1, which is equals to 0. So next, let's simplify this. N square plus n square minus 2n plus 1, n square minus n square minus n minus plus 2n minus n plus minus 1, which is equals to 0. So next, n square plus n square is 2n square minus 2n plus 1, and n square and minus n square cancelled, 2n minus 1. So here we have the two factors and each factor is equals to 0. This implies that 2n minus 1 is equals to 0 and 2n square minus 2n plus 1 is equals to 0. So from this we can derive the value of n. 2n minus 1 is equals to 0. This implies that 2n is equals to 1. I shift the minus 1 to the right hand side, so its sign is opposite. Minus will become positive plus. So here I can find 2 is multiplied with n. It is divisible to the opposite side. So n is equals to 1 by 2. So 2n square minus 2n plus 1 is equals to 0 is similar to ax square plus bx plus c, which is equals to 0. So by comparing this with this equation, I can write a is equals to 2, b is equals to minus 2, and c is equals to 1. Here I'm going to use the quadratic formula to prove this. The value for the value of n, I can write n is equals to minus b plus minus square root b square minus 4ac over 2a. So I have the values, so I'm going to apply these values. Minus 2 plus minus square root minus 2 square minus 4a is equals to 2 and c is equals to 1 over 2, a is equals to 2. So the next I can simplify. Minus and minus will be plus 2 plus minus 2 square will make this term positive. It will be 4 minus 4 to the 8 over 4. So it will be 2 plus minus 4 minus 8 is minus 4 square root over 4. further I can write this as 2 plus minus 4 square root 4. I am going to separate this minus 1 square root and 4 square root over 4. So I can write this as 2 plus minus 1 square root is equals to iota, and square root 4 is equals to 2. So it can be written as, more precisely, plus minus 2 iota over 4. So again, took here 2 as a common term. 1 plus minus iota over 4. So I can cancel here 2 to the 4. So this is equals to 1 plus minus iota over 2. This is the value of n I have found. So here I have the values. N is equals to 1 by 2 and n is equals to 1 plus iota by 2 and n is equals to 1 minus iota by 2.